Welcome back, Math 8 students. Yep, Mr. Frechette back in the action of math. So today we talked about functions. We've been spending, this is our second day spending on functions, and like we talked about, we're looking a lot at functions in general, but most of the functions that you'll be working with are linear functions. So I wanted to go through a couple examples just to kind of reinforce what we've been talking about all along. So, functions. What is a function? Well, a function is a relationship. So when you think of a function, you should be thinking of a relationship between two things, an input and an output. In our case, it is a relationship between x and y. So think of a relationship, and that's what I'm going to say. It's a relationship, right? We all have relationships with our parents, relationships with your aunts, your uncles, whatever, relationships with who you may call a boyfriend or a girlfriend or whatever. Those are all relationships. In this term, we're looking at relationships between x and y. So once again, we're going to mention this again, our x's are also known as our input and our domain values, and our y's are considered our output values and our range values. So the relationship is between our input and our output, our domain and range, or our x and our y, right? Think of it as a machine. If I put in x, I have to get out some y. And it can be anything. Remember, x and y are variables. That can be any number. It's an unknown. So let's go over to our practice. Over here at our practice, we have some of the practices that we've already been looking at. And the practice here is just symbols. So if I was going to label this, we have our input and our output. This would be my x, and this would be my y. Okay? Now our x is representative by shapes or pictures, and our y is representative by numbers. So we need what is called a one-to-one correspondence. So for every x value, for every picture, there should only be one output, right? So that one output is going to be a number. So if we match everything up, we have our smiley face goes with 8, we have our square goes to 1, and then we have our heart goes to 7. Now, you're probably thinking to yourself, Mr. Frechette, well, 3 doesn't go to anything. Well, that's okay. It doesn't have to. So in this situation, because they have that one-to-one correspondence for every x, there's only one y, this is a function. So I'm going to put an F here. And if you notice, the question is asking us which one is not a function. So we're going to go through each one. The next one's the same thing. We have all these pictures. We have a smiley face, we have a square, we have a triangle, we have a heart. Now, we want to make sure our x values aren't repeating themselves, and they're not. So our smiley face goes to 3, our square goes to 8, our triangle goes to 8, and also our heart goes to 7. So now you want to say to yourself, well, hey, Mr. Frechette, this isn't a function. Actually, it is. These x values, these pictures are not repeating themselves. So this is a function. Because think of it this way. Remember, I'm going to bring up that McDonald's example again, right? Can I go to McDonald's, can I get a Big Mac value meal, and can I get a Quarter Pounder value meal, both for $8? Sure you can. They could both be the same price. That makes perfect sense. And because of that, this is a function. We're going to go to our next one. The next one, we have our x and y again, input and our output, our domain and our range, and they're all by pictures and by numbers. So our smiley face goes to 1, our square goes to 3 and 8, and our heart goes to 7. Now, an alarm should be going off in your head. Whoa, 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 Mr. Frechette. The actual square is repeating itself. It has 2 values. Remember, a function has a one-to-one correspondence. That means for every x value, it has its own y value. That's not the case here. This triangle has 2 values, either 3 or 8. Once again, the fast food situation, if I go to Burger King and I want to get a Whopper value meal and then I want to get a double cheeseburger value meal, I can't pay $8 or $3, right? And actually, let me rephrase that. If I go to Burger King and I get a Whopper meal, I can't pay $8 or $3. Okay? So it's that Whopper meal that's repeating itself. So this is not a function. It's an NAF. Okay? So I caught myself there. Even sometimes as adults, we make mistakes because we're thinking about this. You guys are just starting this out. Remember, I've been doing this for a long time. So you really need to think about it when you're looking at these things. And the last one, if you're saying to yourself, is there that one-to-one correspondence? For every x is there one y? Absolutely. These x values are not repeating themselves. Does that mean that a smiley face, a square, and a heart can all be 8? Absolutely, they can. So this is a function. Once again, we'll go back to another fast food situation. We'll go to Taco Bell. If we have a number 1, a number 2, and a number 3 on the value menu, can they all be $8? Absolutely. As long as they're different. As long as they're different menus or different value meals. Okay, they can't be the same thing with 2 different choices for price. So think of it that way. So we're gonna go down to the practice down here. It says, given this set or this relationship, and all this is a table. We've seen some of this. Which of the following values for k will make relation S a function? So I'm going to write it over here. I'm going to change colors just so you guys can see, and I'm going to change it in pink. So in our set, if we set this up as a table, and I know Mrs. McKeechik was talking about this, you don't have to. As you get more comfortable, you will. So remember, this is always going to be our x, and this is always going to be our y. That's for all of them. So for 5, I have -1. For -2, I have 3. For -3, I have 4. And then down here, I have k, which is my unknown, which is fine. And then I have 1. Then I have 2 and -2. And then I have -6 and 0. So I'm going to look at these. 5 is -1. -2 is 3. -3 is 4. K is 1, 2 is -2, and -6 is 0. I just have to make sure that this k value cannot be. It cannot be equal to, and that's how I'm going to put this. It can't be 5. It can't be a -2. And it can't be a -3, a 2, or a -6. It can be any other number that I come up with, right? Because our x values can't repeat themselves. So if we look at our choices, can it be -2? No, it can't, because that would be repeating one of our x values here. Can it be -3? No, because that would be repeating one of our x values. Could it be +3? Could it be +3? Possibly, because I don't see a +3 in my x value, so I'm going to put a circle around this. Can it be 5? No, 5 is already listed as one of my inputs. So it cannot be 5. It cannot be -3. It cannot be -2. So my best choice answer is number 3. Okay? So 3 would make this a function, right? Any other value, 5, -3, or -2, would not make it a function. So I'm going to erase this, and I'm going to move down to one more example, just to show you before we go for today. So I'm going to move this down. Now we have our pictures, right? We looked at this today, which is not a function. So remember, we talked about our vertical line test. The vertical line test is very important. I could take a pen, I could take a ruler, and I could pass it along vertically, right? Our Bucks line, up and down. So I'm just going to draw lines here, just to show you. Does this pass our vertical line test? In other words, does it only intersect the line once? And I did that again. So it's only intersecting once. This is a function. So that's going to be f. How about our second one? I'll use a different color. Let's use red. So we're going to use our vertical line test. I go all the way through. How many times does it hit the function? It only hits it once. So this is a function. And this is because it passes VLT. We talked about that. Vertical line test. And it passes that. Passes with flying colors. The first two at least. Now, we're going to go to our parabola. This is a quadratic function. I'm going to put my lines all the way through again. And yes, it only hits once. So this is also a function because it passes the vertical line test. Now I'm going to look at another parabola or another quadratic function. I'm going to put my vertical line in, and we'll pick another color. Let's pick blue. If I put my vertical lines through, what do you notice? It hits the line or intersects the parabola. The line intersects the parabola twice. So this does not pass the vertical line test. So this is not a function or an NAF. And this is all, these are all examples that we looked at today in the last couple of days in notes. I just wanted to show you again. So, this is what I like to call function fun, and we'll be back to some more function fun on Thursday. Everybody have a great afternoon, and we will see you tomorrow.